Good day everyone. I hope this day brings positivity and productivity to all of us. I am Marlon Asis, and today I will provide a brief insight into how technology is revolutionizing the field of statistics. Modern tools have simplified data collection, analysis, and interpretation, making statistics more accessible and efficient. Topics such as technology tools in statistics and simplified statistics emphasize how innovation transforms data-driven decision-making. At the end of the session, participants will be able to: Number 1, explore various technology tools used for statistical analysis such as Excel, SPSS, R, and Tableau. And number 2, understand the core concept of descriptive and inferential statistics and their applications. Introduction to statistics. Statistics analyzes data for informed decision making. When we talk about this, emphasizes that the primary purpose of the statistics is to analyze data to guide decisions and of course various fields. Technology revolutionizes data analysis and interpretation. Highlights how technology tools are transforming the way statistical analysis is conducted, making it faster and more accurate. And tools improve efficiency, accuracy, and insights. Points out the key benefits of using technological tools in statistics, including improved efficiency, greater accuracy, and the ability to extract deeper insights. Key areas of statistical analysis. Descriptive statistics summarizes key data features. Describes the role of descriptive statistics in summarizing data such as calculating means, median, and standard deviation to get an overview of dataset. Inferential statistics predicts population behavior from samples. Explains how inferential statistics uses sample data to make predictions or draw conclusions about a larger population. And for predictive analysis, forecast future trends and outcomes. Discusses how predictive analytics uses historical data and statistical methods to forecast future events or behavior. And for the data visualization, presents finding through graphs. Highlights how data visualization tools help present data in graphical formats like charts, graphs, making complex data easier to understand. Common technology tools for statistical analysis. Microsoft Excel, SPSS, and Google Sheets list commonly used tools like Excel and Google Sheets for basic statistical tasks and SPSS for more complex analysis, especially in social sciences. For R, Python, SAS, and Stata for analysis. Introduces more advanced tools like R and Python, which offer powerful capabilities for statistical analysis and modeling. And SAS, Stata for specialized industry applications. StatCrunch for cloud-based statistical functions. Mention StatCrunch as cloud-based platforms that allow users to perform statistical analysis and access data from anywhere. R and Python for advanced analysis. R, open source statistical computing and visualization, describes R as an open source programming language used primarily for statistical analysis, offering powerful visualization capabilities. Python, powerful for data manipulation and modeling, highlights Python's versatility in handling and processing large datasets, along with its strong libraries for statistical modeling such as NumPy and Pandas. Data visualization tools, Tableau and Power BI for interactive dashboard. Introduces Tableau and Power BI as leading platforms for creating interactive dashboards that allow users to visualize and analyze data easily. Google Data Studio creates customizable reports. Mentions Google Data Studio as a free tool for creating customizable, shareable reports that can be integrated data from various sources. Machine learning and predictive analytics. Machine learning builds model for predictions. Explains that machine learning, a subject of artificial intelligence, building predictive models based on data patterns, allowing for future predictions. Tools like R, Python handle predictive analytics. Highlights that both R and Python are commonly used tools for implementing predictive analytics techniques and machine learning models. Cloud-based tools and big data. Cloud platforms store and process large datasets. Explains the role of cloud computing platforms like AWS, Google Cloud, and Microsoft Azure in managing and processing massive datasets, offering scalability and flexibility. Big data tools like Hadoop and Spark introduces big data tools such as Hadoop and Spark that enable distributed computing, making it possible to process and analyze large datasets efficiently. Benefits of using technology and statistics. Faster analysis, accurate prediction, and better insights. Emphasizes that technological tools speed up statistical analysis and led to more accurate predictions and better insights from data. Simplifies large data management and visualization. Points out that technology simplifies the management of large datasets and helps in presenting complex data in a more understandable and visual format. Challenges in using technology tools. Steep learning curve for advanced tools. Acknowledges that tools like R and Python may have a steep learning curve for beginners requiring technical knowledge and skills. Cost and data privacy concerns arise. Highlights the challenges related to the cost of using advanced software tools and potential data privacy risk when using cloud-based platforms for analysis. We come down to the next topic, which is simplified statistics. This title introduces the topic and provides the necessary details about the presentation. It sets the stage for an introduction to statistics. What is statistics? Statistics is the study of data. Statistics is concerned with the collection, analysis, interpretation, and presentation of data. It is used in the various fields to discern meaningful insight from raw data. Sample in the survey of 100 students. Statistics can help analyze their performance, preferences, or demographic data. It helps summarize, analyze, and interpret data. The goal of statistics is to summarize large amount of data, analyze trends, and make sense of the numbers. Sample. Supposing teacher can use statistics to analyze students' test scores and identify trends in their performance. Statistics is used to make decisions based on the data analysis. Statistics is used to make decisions based on the data analysis. Statistics helps make informed decisions in business, healthcare, education, and many other fields. For example, a company may use statistical analysis of customer survey to decide which products features to patronize. Types of statistics. Descriptive statistics summarize data. Descriptive statistics are used to describe and summarize data through measures like mean, median, and mode. For example, in a class of 30 students, calculating the average score on a test, mean, gives a summary of overall performance. And we have inferential statistics, predicts trends and make decisions. Inferential statistics use sample data to make generalization or predictions about a larger population. For example, using 100 voters to predict the outcome of an election based on their preferences. Descriptive statistics measure of central tendency, mean, median, mode. These measures describe the center of typical value of dataset, sample mean, average score of 80, 90, and 100 is 80 plus 90 plus 100 divided by 3 is equal to 90. And for the median, middle value in the ordered list for 80, 90, 100, the median is 90. For the mode, most frequent value, if the score were 80, 90, 90, the mode would be 90. Measure of dispersion range, variance, standard deviation. These measures describe how spread out or variable the data is. For example, range, the difference between the highest and the lowest values. For the scores 80 and 100, the range is 100 minus 80 is equal to 20. Variance and standard deviation, measure of how much the data points differ from the mean. A higher value indicates more variability in the data. Inferential statistics involves drawing conclusions from data. Inferential statistics help make conclusions about a population based on a sample of data. For example, after testing 50 students, you might conclude that 80% of all students at a school are passing the course. Uses sampling to estimate population parameters. Sampling involves selecting a subset of data from a large group to make inferences about the full population. For example, surveying 500 customers to estimate the satisfaction level of 5,000 customers. Hypothesis testing helps make decisions. Hypothesis testing is a method used to determine whether a hypothesis about a population is true. For example, testing the average weight of apples from a farm is 150 grams. The null hypothesis mean is equal to 150 grams. And for the alternative hypothesis, mean not equal to 150 grams. Data collection methods. Survey collect data from a sample. Surveys are common method to collect data from a group of individuals. Typically, a representative sample of the population. For example, a survey asking people how often they visit a coffee shop to understand consumer habits. Experiments manipulative variables to observe outcomes. Experiments involve changing one or more variables to observe the effect of another variable. For example, an experiment testing the effect of different fertilizers on a plant growth. Observations gather data through direct experience. Observations involve collecting data by directly watching or measuring real-world events. For example, observing the behavior of a group of students in a classroom to study their interaction with the technology. Basic data visualizations. Bar charts for comparing categories. Bar charts are used to compare different categories of data. For example, bar chart comparing the number of students who prepare various school subjects like math, science, and English. Histograms for showing frequently distribution. Histograms display the distribution of datasets, showing how frequently its value occur within a range. For example, a histogram showing the distribution of students' scores on a test with score ranges on the x-axis and frequency on the y-axis. Pie chart for displaying proportions. Pie charts show parts of a whole, where each slice represents a proportion of the total. For example, a pie chart displaying the percentage of students who prepare different types of extracurricular activities. Sample probability. Probability measures the likelihood of events. Probability is the chance of an event occurring expressed as a number between 0 and 1. For example, the probability of rolling a 3 on a pair 6-sided die is 1/6. Calculated as the ratio of favorable outcomes to the total outcomes. Probability is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. For example, if the deck of cards contains 52 cards and 4 are aces, the probability of drawing an ace is 4/52 or 1/13. For example, tossing a coin, 50% heads and 50% tails. A simple example of probability where each flip of a fair coin has two possible outcomes, heads or tails, with a 50% chance for each. For example, tossing a coin and predicting heads probability is equal to 1/2. Common statistical errors. Sampling bias. When sample don't represent the population, sampling bias occurs. When a sample does not accurately reflect the population it is drawn from. For example, conducting a survey on a student satisfaction but only surveying students from one department may lead to biased results. Type 1 error. False positive, incorrect rejection, or a true hypothesis. A type 1 error happens when a true hypothesis is incorrectly rejected. For example, concluding that a new drug is effective when it is actually not. Type 2 error. False negative. Failure to reject a false hypothesis. A type 2 error occurs when a false hypothesis is not rejected, For example, failing to detect a disease in patients when the disease is present. Why simplified statistics matter? Makes data easier to understand. Simplified statistics help present complex data in more understandable way, making it accessible to a wider audience. For example, showing a student performance with a simple graph instead of a raw numbers. Helps in making data-driven decisions. With simplified statistics, decision makers can rely on the data rather than intuition to guide their actions. For example, a company using sales data to make decisions about inventory and marketing. Essential in everyday life, example in business, health, and education. Statistics play a key role in daily decisions, whether in business, health, or education, by helping analyze trends and make informed choices. For example, health statistics help governments make policies to address health crises such as vaccination rates. That's the end of my presentation. I hope so that you learned something in my discussion. Thank you very much and thank you for listening.